Hello, sir. Hello, sir. Okay. Okay, okay. Now it will go both of them simultaneously. Okay, thank you. Okay, thank you. In the morning session, we discussed about how to. 1 minute. Okay, Unacademy is offering 23% discount. So use GATE code GATE Civil. You can enroll. You can also enroll. They are conducting mock exam free of cost. So without wasting much of our time, let us jump into the course. Okay, morning we have been discussing about mean precipitation by Thiessen scale. So catchment is drawn to some suitable scale, and you need to identify rain gauge stations in a catchment using their coordinates or using information given in the question. You have to identify. Suppose assume there are 3 rain gauge stations. Then what you need to do? Join all adjacent rain gauge stations by straight line. This is station 1, this is station 2, station 3. For station 1, 2 and 3 are adjacent. Station 3, 2 and 1 are adjacent. Station 2, 1 and 3 are adjacent. Join all adjacent rain gauge stations by straight lines. So once you draw straight lines, then draw perpendicular bisectors. Perpendicular bisectors are the lines. So this is that straight line connecting to adjacent rain gauge station. For that you need to draw perpendicular bisector. It should be perpendicular center and perpendicular. So these are the bisectors. Extend them smoothly. Then they divide the center catchment into enclosed between bisectors and boundary is the area of polygon. This is A1. Measure area of this polygon A2. Measure area of this polygon. Measure Thiessen weightage per station 2 is A2 by A. So once you assign Thiessen weightage and multiplying these Thiessen weightages, their respective rainfall values recorded by respective rain gauge stations, you can find out mean precipitation. Clear now? So morning session, those who have attended, they can easily understand this. So usually in the exam and all, to measure this irregular shaped catchment is given, right? Randomly for what they do is, they will give normal, regular, geometrically shaped catchments. Catchment is in the form of a square. Catchment is in the form of a equilateral triangle. Catchment is in the form of a circle. Catchment is in the form of a square plus equilateral triangle. Catchment is in the form of a pentagon, hexagon, octagon, something like that. And how to measure the areas. If you know that much, comfortably you can work out mean precipitation by Thiessen polygon method. If at all any questions in GATE exam from this topic. So I'll explain you with the help of examples. Okay. So otherwise, if Thiessen weightages are known to you, it is only formula substitution. But formula substitution kind of questions generally they don't ask in GATE exam. P bar is equal to, it is P1 into A1 by A plus P2 into A2 by A and so on. There are n number of rain gauge stations method. So Pn An by A. This way also can. So like this formula substitution kind of things they don't ask. They don't give you. So you have to work out this also on your own geometrically by plotting. Okay. By finding areas. That is where difficulty lies for a student. So let us learn. Exam only. So example 1. This is GATE question only. Couple of times. Similar type of question they have asked in many times in GATE exam. So find by Thiessen method. The area is composed of square and equilateral triangle, triangular plot, plot of side 4 kilometers, rainfall recorded at various stations are also given in the figure, are also given in centimeter in the figure. Okay, diagram is given to you, catchment diagram, and you are expected to find out mean precipitation by Thiessen-Polygon method. It is equilateral triangle. Okay, so it is square plus equilateral triangle. Square means all 4 sides are equal. From here, sides also same. Something like this is given to you. Catchment is like this. Okay, he has located rain gauges also. Rain gauges also located. So I will show you these rain gauges in the form of red color dots. These are the rain gauges located. It is also mentioned in the question. At center of the square also one rain gauge station is given. Okay, and respective rainfall values also given there. Rainfall values also mentioned there. This is 3.2 centimeter. This is 4.8 centimeter. Here it is. That's all. Come on, work out now. This question by Thiessen-Polygon method. So as per the procedure, what you need to do? You need to join all adjacent rain gauge station. I'll give some numbers. Rain gauge station numbers are not given, but I'll put numbers. This is station 1. This is station 2. Station 3. Station 4. I am placing numbers. Station 5, Station 6. I'll give in the rounds. These are the rain gauge stations. 6 stations are there. Then as per the procedure, what you need to do? First you need to connect all adjacent rain gauge stations by straight lines. I will do this. For your understanding purpose, side by I will draw this and I will work out. So all adjacent rain gauge stations we need to connect by straight lines. Some of them already connected, some of them not connected. So these are the rain gauge stations. Station, this is station, this is station, this is station, this is station, and center also there is one more station. I am connecting all adjacent rain gauge stations by straight lines. Those straight lines I am plotting by black color. Already these are connected. This is connected. So this is station. I took this as station 1. This is station 2, station 3, station 4, station 5, station 6. For station 1, adjacent rain gauge stations are 5 and 2 and 6. So each side is given as 4 kilometers. This is 4 kilometers. Side is given as 4 kilometers. All 4 sides are equal now. All sides. Equilateral triangle also same length. All sides are equal. 4 kilometers. This is also 4 kilometers. So if 4 kilometers distance or less than 4 kilometers is treated as adjacent rain gauge station. More than 4 kilometers is not treated as adjacent rain gauge station. Therefore, if for 1, 2 I will join. For station 2, 1, 6, 3 are adjacent. So I will join 1. Already 1 and 2 connected. 6 also I will connect. For station 3, 4 is adjacent, 5 is adjacent, 6 is adjacent, 2 is adjacent. So 3 and 2 already joined. I will also join these 2 and this also. 4 is adjacent. Already connected. These 2 are not connected. I will connect. Now all of them are connected by, for 6 all these are adjacent rain gauge station. 1, 2, 3, 4, 3, 5. But 4 and 6 are not adjacent rain gauge stations. You can't join like this because it is more than 4 kilometers. 4 kilometers and less than that or less than that value is only treated as adjacent rain gauge station. Now I will draw bisectors. So when you draw bisectors for this is bisectors for this station. Center and perpendicular, center and perpendicular, center and perpendicular, center and perpendicular. So we know how to draw bisectors for equilateral triangle. So if you join them, center and perpendicular, center and perpendicular, center and perpendicular, and smoothly if you extend, they will join like this. Then how much area will go to station 1? This much area will go to station. Station 2 represents same area. This is also same. Station 1 and station 2 represent triangular area. So this area, triangle. So the total is 4 kilometers. This is half bisector, no? So from here to here it is 2 kilometers. 2 kilometers, 2 kilometers. Therefore, A1 is equal to, A2 is equal to, it is half into B into H. So it is 2 kilometers square. So this is A1, this is A2. These two are same. For station 3, area enclosed between bisectors and boundary. Station 3 and station 5 both have got same area. Area enclosed between bisectors and boundary. This total area will go to station 3. This total area will go to station 3. So this is triangular area plus 1/3 of equilateral triangular area. 1/3 of equilateral triangular area come from equilateral triangle, and 1/2 BH will come from square. So total area will go to station 3. So for station 3, how much area will come? This is half BH come from square, and 1/3 of equilateral triangle area come from, right, this one, equilateral triangle. From equilateral triangle you will get 1/3 area. This is 1/3 of equilateral triangle area. This is square area. Square area we know. A3 and A5 both carry same area. So it is half into B into H for square, for triangle, plus equilateral triangle 1/3 of root 3 by 4 A square. Morning discussed. Area of equilateral triangle is root 3 by 4 A square. So when you draw perpendicular to bisectors by placing rain gauges on the periphery, so they share equal area. 1/3 of root 3 by 4 A square. A square is 4 square. Okay, come on, work out that value. How much it is? So root 3 by 4 So it is 2.309 plus 2. So it is 4. So we got A3 and A5. So both of them carry same area, these two. So this is A3 and A5. Of root 3 by 4 A square, it is like this. After drawing bisectors and all. So A4 is equal to, is 1/3 of root 3 by 4 A square, which is equal to 2.309 kilometers square. Then what is left with you? This is A4. This 2, this side 2, this is root of 2 square plus 2 square, root 8. Root 8 into root 8. So what is left with you? Diagonal area. This is A6. So this side it is 2, this side it is 2. Diagonal is equal to, it is root 8. This side also root 8. So A6 is equal to, it is root 8 into root 8. So it is 8 kilometers square. Understood now? Root of 2 square plus 2 square. So it is root 8. This side it is root 8. This side also it is root 8. Square, no, diagonal it is. All sides are same. So it is 8 kilometers square is the answer. So we got areas. Now rainfall values already known to you. Can't work out by mean precipitation. So P bar is equal to, it is P1 into A1 plus P2 into A2 plus P3 into A3 plus P4 into A4 plus P5 into A5. 6 stations are there. P6 into A6 by total area. What is total area of catchment? Total area is equal to area of equilateral triangle plus area of square. Area of square is 4 into 4. Area of equilateral triangle is root 3 by 4 A square. Root 3 by 4 A square. This is total area of catchment in kilometer square. Come on, now substitute. What is P1? P1 is equal to 8 centimeter. Its area is equal to 2 kilometer square. So which is equal to 8 into 2 kilometer square. P2 is, what is P2 value? 13 centimeter. Its area also 2 kilometer square. So 13 into 2 kilometer square plus P3. P3 is 4.8 centimeter. Its area is equal to 4.309 kilometer square. 4.8 into 4.8 only, no? 4.8 into 4.309 kilometer square. And P4 is 3.2 centimeters and its area is 2.309 kilometer square. Understood? 3.2 centimeters into 2.309 kilometer square. Then A5 is this one, A5 5.4 is 5.4 into 4.309 kilometer square, plus A6 is 9.4 centimeter. So 9.4 centimeter into, then this one is how much? 8 kilometer square. 8 whole by total area. Total area is equal to how much it is? So it is 4 into 4 square area plus root 3 by 4 a square, equilateral triangle area. Come on, work out this value. How much you are getting? Come on, find out. So calculation you should carry out. Come on, type the answer there. So I am getting 7.4 centimeters. Have you got 7.4 centimeter? Come on, verify. Oh, sorry, not 7.4. How much you are getting? 7.35. So I am getting 7.35 centimeters. Are you getting 7.35 centimeters? Then it is right. So this question, same type of question by changing the data 3-4 times they have asked in last 20 years in GATE exam. Okay. Let us try a few more problems. Clear now? If any doubt is there, you can type there. But answers you are not giving. You are not giving a questions you solve, then you will get expertise. This question has been asked in ESE exam. Example 2. A, B, C, D and E are located of diameter. Compute the mean annual rainfall. Compute the mean annual rainfall over the basin using Thiessen polygon method. If the rainfall at stations A, B, C, D, E and E are 100 centimeters, 80 centimeters. It is given to you with rain gauges. So it is in the form of a circle. Circle of diameter so and so given. So he mentioned that rain gauge stations are located one at center of circle, remaining all are located on the periphery. These are the peripheral stations. So station, this is located inside circle A, then this is B, this is C, this is D. So what you need to do? You have to connect all adjacent rain gauge stations by straight lines. Okay, try this question. Chandan sir, DRDO exam or any exam, syllabus is same. You can crack any exam if you know the content. Your concept is strong, then you can answer any question from any exam. That's what I am saying. So as per procedure, what you need to do? You have to connect all adjacent rain gauge stations by straight line. For A, B, C, D, E, all of them are adjacent rain gauge stations. Therefore, I connect all of them by straight lines. This is like this is given. So solution. So let me solve in another page. So like this is given. Okay. We connect all adjacent rain gauge stations by straight lines. So adjacent rain gauge stations are now connected. So this is A. For A, B is adjacent, C also adjacent, D also adjacent, E also adjacent. So they are all connected now. Okay, and we have to connect the remaining adjacent. They are also adjacent, and D and C also I need to connect adjacent. D and E also adjacent. B and E also adjacent. Bisectors divide this entire catchment into number of polygons. So bisector for this line is center and perpendicular. This is a bisector for this line. This is bisector for this line. This is bisector for this line. This is bisector for this line. Similarly, for this line, this is bisector. Join these two. For this line, this is bisector. For this line, this is bisector. For this line, this is bisector. So if we join all adjacent lines, then this whole area is divided into number of polygons. How much area will go to this peripheral stations? All peripheral stations carry same area. How much area they'll take? So area enclosed between bisectors and boundary. So what is that area? This area. All peripheral stations will take this much area, and central station take how much area? This area. This area will go to central station. Central station take this area. Okay. So peripheral stations are different, central station is different. So all peripheral stations take how much area? It is AB is equal to AC is equal to AD is equal to AE is equal to, it is square area, circle area minus square area. Circle area is pi by 4 d square minus square area is this square, small square is there, no? Big circle minus small square by 4. So I will take it as, I will write here, total circle area minus small square area inside. So circle area minus square area by 4. Okay, they will take this much area, each station. What is circle area? What is circle area? Diameter of circle is given as, how much it is? Diameter is 20 kilometers. So therefore, which is equal to, it is pi by 4 into 20 square. If it is 20 kilometers, what is the length here? It is connected between this to this. This point to this point is radius. It is 10 kilometers is radius. From here to here 5. From here to here 5. So this is 10 kilometers. This is also 10 kilometers. So square area is equal to, it is 10 into 10. by 4. This is for all stations lying on the circumference. For central station, this is AB, no? This is AB is equal to, AC is equal to, AD is equal to this AE. So all of them lying on the periphery, all peripheral station, this much area will get. And central station is, it is 10 into 10, 10 kilometers square. Now let us work out mean precipitation. So total area is equal to pi by 4 into 20 square, circle area. So therefore P bar is equal to, it is P1A1, oh sorry, PA into AA plus PB into AB plus PC into AC plus PD into AD plus PE into AE by total area. So PA is given in the question 100 centimeter. A station is 100 centimeter. So it is 100 into 10 into 10 by 4 into PA is different, PB is different, PC is different. Areas only same. So 90 plus 110 plus 120 plus 80. 90 plus, this is PB, 110 plus 120, 80 plus 120. He was given 100, 100, 90, 110, 120, 80. 90, 110, 120, 80 plus 80 by total area of circle, pi by 4 d square. Understood? So this is how we need to work out. Pi by 4 into 20 square. Come on, work out. Answer, I need answer. So answer for this is, I am also using calculator along with you. So it is, let us first work out pi by 4 into 20 square minus 100 by 4 into 90 plus 110, 200, 200 plus 200, 400 into 400 plus 100 into 100 divided by pi by 4 into 20 square. Hundred centimeter. That was the answer for this question. I got 99.99. So it is 99 centimeter. It is rounded to 100 centimeter upon calculation. Anybody got 100 centimeter? Come on, type there. You should help me in finding the answers. Oh, no one is there. When I am asking answers, you are disappearing from here. So online coaching means you are not at all serious. You are not serious, you don't get. Sometimes you will find 4 people, sometimes you will find no one. So this is how we can work out. Let us try one more question. A catchment is in the form of a regular hexagon of side 10 kilometers. Rain gauges 10 kilometers as shown in figure. Okay, I will give you diagram also, because civil engineers might have forgotten their concepts. One at each corner and one more at center. Recorded 5 centimeter, 30 centimeter and 40 centimeter at its central station. Find mean precipitation by, see as given, it is something like a regular hexagon. Regular hexagon is made up of 6 equilateral triangles. This is one equilateral triangle, 2, 3, 4, 5 and 6. Rain gauges located one at each corner. This 1, 2, 3, 4, 5, 6. One more at central station. Central station is 6th station. And rainfall value is also given to you. So P1 is 5 centimeter, P2 is 10 centimeter, P6 is 30 centimeter, and 1, 2, 3, 4, 5, 6, and P7 is, this is 7th station, central station. P7 is 40 centimeter. Then you have to find out mean precipitation. Come on, try. This is how he has given. 6 equivalent triangles you join. Each side is 10 kilometers. You will get one regular hexagon. Hexagon means 6 sides. All 6 sides are equal. 1, 2, 3, 4, 5, 6. Pentagon means 5 sides. Hexagon means 6 sides. Come on, work out. So what to do? So this is a regular hexagon. Separately I am drawing again. So already all adjacent triangle stations are connected. You need not do it. 1, 2, bisector. For this line, this is a bisector. For this line, this is a bisector. For this line, center, bisector, center, bisector, center and 90 degrees. These are the bisectors. So bisectors are drawn. Now you join all the bisectors smoothly. If you extend this bisector, join, and this will go and join this and as well as this. These are the bisectors now. So all these bisectors divided this area into, this whole area will go to this station. This whole area will go to this station. All peripheral stations, they get equal area. Okay. So A1 is equal to, A2 is equal to, A3 is equal to, A4 is equal to, A5 is equal to A6. All peripheral stations carry equal area. So how much area? 1/3 from this triangle, from this. Root 3 by 4 into A square. A is 10 square. Central station, how many equivalent triangles? 1, 2, 3, 4, 5, 6. For A7 it is A square. This is central station. Then total area, this is equal to area of 6 equivalent triangle. Root 3 by 4 A square. This total area of hexagon. Okay, now you can work out. So P bar is equal to, so it is P1A1 plus P2A2 plus P3A3 plus P4A4 plus P5A5 plus P6A6 plus P7A7 by total A square, that is common. P1 5 centimeters, P2 10 centimeters, P3 15 centimeters, P4 20 centimeters, P5 25, P6 30. Plus central station 6 equilateral triangle, 1/3 root 3 by 4. So 6 into root 3 by 4 into 10 square. So all root 3 by 4 10 squares will cancel out. This root 3 by 4 10 square cancel out here. Here also cancel out. Then remaining, if you simplify, you will get answer. So remaining is 2 into 1/3 into 15. So this is without calculator also you can manage. So mean precipitation is 25 centimeters. Understood? Root 3 by 4 10 squares I cancelled out. So this is how we can work out mean precipitation by Thiessen-Palgan method. So I have solved different kind of questions. One more example you want to take, you can take. Example 4. So as given square type catchment. Outside 6 km, he kept here, rain gauge station, another station here, another station here, another station here, another station here. So this is numbering also done. 1, 2, 3, 4. Central station is 5. By Thiessen polygon method. So station 1, rainfall value is given as P1. So this is 3 centimeter. This is 5 centimeter. This is 2 centimeter. This is 6 centimeters. This is 4 centimeters. 3 is 6 centimeters. P4 is 4 centimeters. P5 is 2 centimeters. So we have to work out. Then what to do? So as per the procedure, what you need to do? First you have to connect square type of catchment. This is. You have to connect all adjacent rain gauge stations by straight lines. So he has not put on the periphery. He kept inside rain gauge stations. One station is here. One station is somewhere here. Another station is somewhere here. Another station is somewhere here. One more at center. Straight lines. So for station, these two are adjacent. These two are adjacent. These two are adjacent for this. So now all of them connected by straight lines. Okay. So all adjacent rain gauge stations are now connected. Station 1, this is station 2. This is station 2. This is how it is numbered. Same way you have to number. This is station 3. This is station 4. This is station 5. Bisector for this line. This bisector for this line. Bisector for this line. Similarly, bisector you draw. It should pass through center of this connecting line. 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 So how much area will go to peripheral stations? This much area. A2 is equal to A3 is equal to A4, which is equal to big square area minus small diagonal square area by 4. So big square is 10 into 10. So diagonal is how much it is? So from here to here it is, from here to here it is 10 kilometers. 10 kilometers. Clear? So he has to mention there where exactly it is located. So this is located at a distance, let us assume 2.5 kilometers from this side, from this side. So this is located from here 2.5 kilometers from every corner. All of them located in the same way. If this is 2.5 kilometers from here, 2.5 kilometers from here, so remaining is how much? 5 kilometers. So this side it is 5 kilometers, this side it is 5 kilometers. Understood? If this is 5 kilometers, this is 2.5, this is 2 minus diagonal area. This will give that one. Big circle area is 10 kilometers by 10 kilometers. Side is 10 kilometers no given. And he mentioned that here, okay, 2.5, no, I'll put this one, 2.5 is too much. From here to here it is located at a distance 1 kilometer, 1 kilometer. 1 kilometer from every corner they are located, 1 kilometer. So 1 kilometer, 1 kilometer, if you subtract 1 kilometer, 1 kilometer, remaining is 4 kilometers. Out, this is 2 kilometers, this is root of 2 square plus 2 square, root 8. This is root 8, this is root 8. Understood? Here, this is 1 kilometer from here. Then remaining is how much? 4 kilometers. This is 4 kilometers. Similarly here in this direction also same thing. 1 kilometer here again 1 kilometer. So this 1 kilometer. Then what is the distance between these two? This is this diagonal area. This diagonal is equal to how much? 2 kilometers. This is 2 kilometers. This is 2 kilometers. Understood? Then this distance is this side also root 8. So this is root 8 and root 8. So 6 into 6 minus root 8 into root 8. Okay? A1 into A2 into A3 is equal to this much. It is 6 into 6 minus root 8 into root 8. 8. 36 minus 8. That is A5 is equal to, it is a diagonal area will go to central station. Diagonal is root 8 into root 8. It is 8 kilometers square. That's all. Then we can work out. So P1 is given as, here rainfall recorded is 6 centimeters. Station 3 6 centimeters. Here rainfall recorded is 4 centimeters. Here it is 2 centimeters. Therefore, P bar is equal to P1A1 plus P2A2 plus P3A3 plus P4A4 plus P5A5 by 4 parts. It is 7 kilometers square into P1 is 3 centimeter, 3 plus 5 plus 3 plus 4. 3 plus 5 plus 6 plus 4. 6 plus 4 plus remaining is 8 kilometers square into 2 by total area. Total area is 6 into 6, 36. Come on, work out. By 4 this is. Understood? Square area minus diagonal area. You have to work out. A1, A2, A3, A4 are same, which is equal to square area minus diagonal area by 4. So A1 is equal to, A2 is equal to, A3 is equal to, A4 is equal to, it is total square area 6 into 6 minus the diagonal area. This diagonal is root 8 into root 8 by 4. By 4. So which is equal to 6 into 6 plus root 8 into minus root 8 into root 8 by 4. So it is 7 kilometers square. Understood? Diagonal is for central portion. So A5 that is. Total area minus A5 by 4. Total area is 6 into 6. A5 is this one. This is A5. This diagonal portion. Root 8 into root 8. Understood? Come on, work out now. 3 plus 5, 8, 14, 18. 18, 7 into 18. So 7 into 18 plus 16 by 36. So mean precipitation is how much it is? 3.94. 3.94 centimeters. That was the answer. So this is how we can work out the questions related to mean precipitation. If you are comfortable with this, comfortable? No one is watching, then whom I can ask? Okay, then I'll go to next topic. Isoheital method. This is also formula substitution kind of method only. This is more accurate among all methods. So isoheight is a line joining the points of equal precipitation. Isoheight is a line joining the points of equal precipitation. Okay, or equal rainfall. Line joining the points of equal rainfall. Equal snowfall is called isonif. Isoheight is rainfall, isonif is for snowfall. Equal rainfall. So line joining the points of equal snowfall is called isonif. Equal snowfall is known as isonif. Isonif is different, isoheight is different. So this method also, practically it is not that easy, but theoretically it is easy. For us, somebody give you a catchment with isoheital lines. They will draw isoheital lines. Then what our job is, we need to find out area enclosed between two isoidal lines and their respective rainfall values, if you multiply, you will get the total precipitation. Okay. Let P1 comma drawn over a catchment. Drawing isoidal lines is not that easy, but in the exam you are not expected to do that. Therefore, somebody will draw for you. Your job is use them and work out mean precipitation. Drawn over a catchment of area A kilometer square or area A. It could be kilometer square or anything. Okay. And A1 comma A2 dot 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 an minus 1 be the area enclosed between successive isoidal lines. Successive isoidal lines. So this and all will be given to you. And isoidal lines are drawn over a catchment with areas also given to you. This is a catchment. So they will give you this isoidal line for P1 rainfall, this isoidal line for P2 rainfall, this isoidal line for P3 rainfall, P4. Like this total catchment, right? Isoidal lines are drawn over a catchment. Then area enclosed between them also given to you. A1, A2, like that. N number of, so therefore, rainfall between rainfall in an area enclosed between two successive isoidal lines is equal to of course they are successive only between isoidal lines between isoidal lines Pn and Pn plus 1 is equal to, in general, or Pi and Pi plus 1 is equal to Pi and Pi plus 1 is equal to rainfall in an area Ai enclosed between two isoidal line Pi and Pi plus 1 is equal to average isoidal value, that is taken as average isoidal value. What is that average isoidal value? It is Pi plus 1 by 2. Okay, that is rainfall. Then Pi and Pi plus 1 is equal to Ai into depth of rainfall. So Ai into Pi plus 1 by 2. This volume of rainfall. So total volume of rainfall from the entire catchment is equal to how much it is? So total volume of rainfall collected in entire catchment is equal to, so you have to sum up all those things piece by piece, you have to sum up. So sigma of A into Pi plus depth only, the catchment by catchment area, total volume of rainfall collected in a catchment by catchment area. So 2 by area of catchment. So this will give mean precipitation by isoidal method. But somebody has to give isoidal lines. If you expand and write this equation, you can write like this. So therefore, P bar is equal to, you can write expand and write as Pi plus 1 by total area of catchment. So if you expand and write, what you can write? A1 into this P1 plus P2 by 2 plus A2 into P2 plus P3 by 2, so plus so on to An minus 1 into Pn minus 1 plus Pn by 2 by total area of catchment. If you expand and write, you will get like this. Understood? This is so simple and so easy. Understood? So in this portion A3, P3 plus P4 by 2, like collected from a catchment by total area of catchment will give mean rain precipitation. So simple and so easy. So finally you have to remember this equation. Sometimes what happens is at extreme ends purposefully he will not give any isoidal line. So at extreme corner isoidal line is not given. Suppose for example it start with P2 only. P1 is not given. P2, P3 like this. Remaining values are given up to Pn. Then what is rainfall in this A1 portion? Nearest isoidal value is taken as rainfall in this portion. This A1, A2 like this. So at extreme ends, at extreme coordinates, at extreme end of a catchment, if isoidal line is not given, then in that portion rainfall is taken as nearest isoidal value. Okay, I'll write in next page. That point you have to remember. Sometimes to confuse you, so at the extreme coordinates you will miss in giving that is the isoidal line. Purposefully, intentionally does. Then in such case what you need to do? Nearest isoidal value is taken as rainfall in that portion. For example, something like this. I'll draw a little bit more. Little bit large sketch I'll draw. At extreme coordinates, if rain gauge station, isoidal line is not given, whatsoever may be the reason, then in that portion we can't take it as P1 is equal to 0. There is no 0 isoidal line. So you can't start with the P1 plus P2 by 2. Slightly you need to fine tune this equation. Suppose this is a catchment given like this. At extreme end, he has not given purposefully. So he started with the P2 only. P1 is not given. He started with P2, then P3. So like this remaining portions he has given up to Pn. Then in this portion it is A1, A2 like this up to An minus 1 is given. So in this case what you need to do? You have to just fine tune that equation, that's all. So at extreme portion of catchment, isoidal line is not given. Purposefully, rainfall is taken as nearest isoidal value. So in this portion, rainfall in this portion is P3 plus P4 by 2 like this. Remaining portions no problem. It is Pn minus 1 plus Pn by 2. Here only, last portion only, there is a problem. So therefore, then P bar is equal to, you can start like this. It is A2 into P2 plus, then A3 into P3 plus P4 by 2. And then you can write remaining portions, no issue at all. Up to An minus, we start nearest isoidal value is taken. Knowing the subject, you are the name of the course. Teaching. Realize thing is there. The two ice 45 centimeter and 55 centimeter is kilometer square. What is and 52 centimeter, 60 centimeter. For three isoidal lines are given. It is 150 kilometers. What is average depth? 150, 250 kilometers square. AI into PI plus 1 by 2 by total area of catchment. 5 by 2. Without calculator you have to work out. By 250. So now let us work out without calculator because this is ESE question. So it is 100 kilometers square. 45 plus 55 by 2. 45 plus 55, how much it is? 45 plus 55. 100, no? 100 by 2, 50 it is. So 100 into 50 plus 150 into 55 plus 65, 50 plus 60, 110, 110 plus 10, 120, 120 by 2. 120 by 2 means 60 by 250. So we'll get straight away in centimeters because they are given in centimeters, right? 55 centimeters. So if we simplify, we'll get answer. This is 25. All zeros I can cancel out. This 0, this 0, this 0. Then 10 into 50, 500. 500 plus 15 into 60, 900. 900 plus 500, 1400. 1400 by 25. So that's how we can manage without calculator also. Without calculator also you can manage. So this is 1400 by 25. It is 56 centimeter. Or otherwise we can simply cancel out 25 anja. This is, you can cancel out like this. Let it be 150. I'll cancel this 0. This 0 I'll cancel. Then 25 2 ja, this is 25 1 ja, 25 2 ja, this is 25 into 6. So now 10 into 20 plus 6 into 36. 10 into 20 it is 20 plus 36. So it is 56 centimeters. That's where you can work out straight away without calculator. 56 centimeters. That was the answer for this question. Let us see given options 56 is there or not. 56 is there or not? Yes. So this is the answer for that question. Understood? So I thought of starting frequency analysis also, but I could not start frequency analysis because this is not yet completed. One more, let us try. One more question for this method, by this method. Example 6. So this question also given like this. The isoids due to a storm in a catchment were drawn. And the area of the catchment bounded by isoids, that means enclosed by isoids. Were tabulated below. Estimate mean precipitation due to the storm. Of course, he has given options also, and he has given table isoidal lines are given, isoheights in centimeter, that is rainfall, they represent rainfall only, and area enclosed between them in kilometer square. So nothing is given. Station, no isoid is there. Station and 12, and 12 and 10, and 10 to 8, then 8 to 6, and 6 to 4. Station, this is area enclosed is 30, this area enclosed is 140, this area enclosed is 80, this area enclosed is 180, this area enclosed is 20. Right? The options given as A 12 centimeters, B 8.84 centimeters, C 7.8 centimeters, D 12.2 centimeters. Purposefully here it is not an isoid. This is not an isoid. This is not isoid. Nothing is given. So it's starting with the 12. It is starting with the 12. So he has given like this. It is starting with the 12, then 10, then 8, then 6, then 4, then 4. Like this is given. These are the isoidal values. Then area enclosed between them also given to you. 30, 140, 80. This is 30, this is 140, This is 80, then 180, 20. This is 180, this is 20. He has given like this. What is mean precipitation? He is asking. So whenever like this is given, what is the rainfall in this portion? 12. Rainfall in this portion 12 plus 10 by 2. Rainfall in this portion 10 plus 8 by 2. Rainfall in this portion 8 plus 6 by 2. Rainfall in this portion 6 plus 4 by 2. So whenever it is not enclosed at extreme corner, nearest isototal value is taken as rainfall. So it is A1 into, I will take it as A1 into P2 plus A2 into P2 plus P3 by 2 and so on. AN minus 1 into, like that. Understood now? Equation I need not write. I am straight away working out by substituting in the formula. So what is the volume of rainfall collected in this portion? It is 12 into 30 or 30 into 12 otherwise. A1 into P1. So A1 is 30, P1 is or P2 otherwise 12. Then 140 into 12 plus 10 by 2 plus 80 into 10 plus 8 by 2 plus 180 into 8 plus 6 by 2 plus 20 into 6 plus 4 by 2 by total area. What is total area? If total area is given, if not given, we'll sum up all this. 30 plus 140 plus 80 plus 180 plus 20. On work out mean precipitation. So it is 30 into 12 plus 140 into 12 plus 10 by 2, 22 by 2, 11 plus 80 into 9, 18 by 2, 9 only, plus 180 into 7 plus 20 into 5 by 30 plus 140 plus 80 plus 180 plus 20. So I got 8.84 centimeter. So I got this value as 8.84 centimeter. That was the answer for this question. Let us see 8.84 is there or not. Yes, it is there. So this is the correct answer. Understood now? So calculators are allowed in GATE exam. You can use calculator. Why 30 into 12? Attend class. The extreme corner isototal line is not there. Whenever extreme corner isototal line is not there, what you need to do? I wrote here. In extreme ends, at extreme portion of catchment, isototal line is not given. Then in that portion, rainfall is taken as nearest isototal value. Hello, Indian. Indian or Pakistani are? Only Pakistani is there. They think like that. I wrote already Indian. Understood? That's all. This is how we can work out questions. So I could not start frequency analysis of rainfall today. So next class, maybe tomorrow I will take at 8 to afternoon 8 to 10 or 8 to 9:30 I will take. It's tomorrow because morning time I am not available. So afternoon I will take tomorrow. Do attend class. Frequency analysis is very important. You can get one question from that topic in GATE exam. Frequency analysis of rainfall data. So tomorrow I'll start. I could not start this topic today. The reason being, I have not completed that mean precipitation topic because that is also very, very important for exam point of view. Okay, numericals, I'll write frequency analysis numericals today or tomorrow's topic. So we'll solve numericals, we'll complete that. Once frequency analysis is done, you are perfect in precipitation. Okay, maybe I'll take 8 to 9:30, 8 to 9:30 or 8 to 10 tomorrow. 8 to 10 p.m. class I'll take, then I'll try to complete that frequency analysis tomorrow. Any doubt is there, you can ask me, you can type there. Okay, Indian, thank you very much for your patience, patiently hearing the class. I'm very happy for that. Second channel, nobody is attending. Okay then, this Unacademy is offering 23% discount. Want to avail that offer, you can avail that offer soon going to end. A good chance, 23% discount is not a small amount, reasonably very good amount that is.